Okay, so what do you have in mind for today?
So in our last video, we went over crawler that I created for parsing all the comments on the monthly posts on Hacker News, where
Hmm.
people post if they are looking to hire folks, right?
Yep.
So if you remember, uh, if you download all the posts, sorry, comments, right?
Hmm.
So this is the kind of content that you're going to get at the end of the day.
All right.
And if you see, this is HTML content.
Hmm.
Right? So viewing HTML content in text editor is not that interesting. And if I want to basically figure out what the links are, or I just want to figure out what the text is,
Hmm.
it's not that obvious.
Right.
So there are two things that you can do then,
Hmm.
right?
Hmm.
You can either add logic in the crawler, or maybe create a separate application which you can basically then add in pipeline
Hmm.
after the crawler, which will separate out the text from the HTML content that you get for the comment.
All right.
Or what you can do is, instead of putting in all your effort and energy into parsing HTML content,
Hmm.
you can make use of something which is just built for that purpose, which is you use a browser, right? So
All
if you
right.
just create an HTML page
Hmm.
and with this content and load it in a browser, you will see the content as it is intended to be viewed.
Right.
So so I decided on the second approach, where I just wanted to create an HTML page for every comment and just view it in a browser, right?
Hmm.
And to make things simpler, uh, I wrote a small web server in Golang to basically load this content, uh, put it in a templated HTML page, and push that content to the browser when the browser makes a request for the content.
Okay.
Right? So if I just, okay, I don't even remember. Oops, I'm not even sure if this is working as I expect, but let me try giving it a shot.
So you have launched a local server.
Yes, and let me what is uh, just pick some entry from here,
Hmm.
right? And this is how you get it, right? So this is the content of the comment. This is the action that you can take on top of it, and yeah, I just created some sample uh, title here.
Hmm.
So if you just view the HTML that you get, right? It's
Hmm.
very simple. What you have is you've got one div block
Hmm.
where you have the entire content that
Hmm.
you pulled from Hacker News,
Okay.
right? And you just put it here. You've also got one div block which basically contains a form button, which basically contains a form which has three buttons.
Hmm.
So usually a form, right, has a single button, but you can add multiple buttons on the form, right?
Right. Okay.
And for every button, there are submit buttons, and I've given an action, right?
Okay.
And this action is generated dynamically. So basically, it's the accept API, and
Hmm.
you give it a ID, which is the comment ID, which is the same thing that you're viewing, right?
Hmm.
Or you can have a reject. And what basically happens is when, say, so basically the way the server works is it exposes uh, some APIs, right? So there are
Hmm.
three APIs that it gives for any object that it has. So
Hmm.
you've got a view API, you've got an accept API, and a reject API.
Okay.
Uh, so for any comment ID that you give it, right, what it is going to do is, if we go back to the way in which we have stored our content, right,
Hmm.
uh, we've got three folders: accept, reject, and review.
Okay.
So all the view content comes from the review folder. All
Hmm.
the accept content is there in the accept folder, and the reject content is in the reject folder.
Hmm. So initially
Okay.
everything that you fetch from Hacker News, you put it in the review, I assume.
Exactly. So
Okay.
all the content that was passed, that was scraped from Hacker News, we put it in the review folder. And once that is done, then to get started with, you pick up a valid ID, right?
Okay.
And you basically you initiate the local server, and you can basically view the content,
Oh, okay.
right? Uh, So yep, and the buttons do very simple things. If you click on accept, what it is going to do is it is going to move the entry from the review folder to the accept folder, and the same similar activity happens if you click on the reject button, so it will move it to the reject folder.
Okay. So it moves, not copies. So it will go
Yeah.
away from the review.
Yes, it should move the content. That is that is how I've designed it.
Okay.
And there is one more button for exit, where if I click on exit, it should shut down the web server.
Okay.
Right. So if we go on the web server, right, this prints a bunch of lines calling that it is gracefully terminating.
Mhm.
I do not believe it is gracefully terminating, but sure, like you can always lie your way through it. Right. For now, let's just assume that it is gracefully
So
terminating
let's take a
because
look
the
at
job is.
this job server, right? So how have you exposed these endpoints?
Sure. So let's just look at server.go. Right.
Okay. So this is
This
completely different from your scraper or
Yes, this is completely. So this I created as a separate project. I mean, it could have been the same project, but yeah, I just decided to. It's a single file. It has I think around what, yeah, almost 100 lines of code, and yeah, this
okay.
creates a separate binary, right?
So most of those look like packages. What is this text template thing? Looks like
Yes,
something new.
yeah. So this is a package. The text template is a package.
Hmm.
Regex is also a package. I don't think I've
Hmm.
discussed this earlier,
Nope.
right? All these errors, OS. I'm not sure if I've used sync earlier, but sync is also a package. String convert is also a package.
Okay.
Right?
Have we
So
used all of these in this file now?
oh yeah, I mean we have used all of them.
Okay. Let's see them when we see them then. Okay.
Sure. Before I go there, right? Let's just go back. Let's just start the server again. Let's just view this content again, right?
Okay.
So I'm just going over this again because I just want to highlight what is missing, right? So say I do
Okay.
not give an ID, right? So it's just going to give you a 404 and just script that, hey, we do not find anything.
Looks like
Right?
a custom 404 page though.
Sure, yeah, it is custom. I had to fix this also. That yeah, it's giving me is saying it's giving the message twice. Yeah. So yeah, so the code is not that clean. It has some issues. I have not cleaned it up, but yeah, so that's one issue with this. Yeah.
Okay.
Right. But again, so if you think about it, right? So the way you would want it to be is that, say, if I do not give you any ID, then it should give me a list of all IDs which are valid that I can view. Right.
Yep.
So that is what the intent is. I have not gone about implementing it yet. So till the time it's not there, I just wanted it to give you a 404.
Okay.
Right. Similarly, what you also want is if I do not specify any apps, if I do not specify any endpoint, right? And if I just want to access the root, right? So okay, so it's going to front page, and I'll come back to why it says front page sometime later. But basically, you can just assume that it is trying to redirect you to a default page, right? And what do you want on the default page? Well, what we were discussing earlier, right? That we want to come to the default page, and it should basically again give you a list of all the content that you can view, right? That you can review, because that is what the whole intention of this server is, to give you a list of content to review. Once you're done with it, sure, you can exit, right? And that's also the reason why we have an exit button also, that after viewing, say, all the entries that you have, you will want to exit, right? And that is why I created the exit endpoint, so that you don't have to go and then kill the server separately. You can just initiate that from the browser itself.
Cool.
So that is what that is. Okay. And okay, so let's come to the code. So now that we've talked about it, right? So, okay, even before I go over the code, I just want to highlight the fact that the code is inspired from a tutorial on Golang. So there is a Golang wiki tutorial that I had read, and then yeah. So this is the tutorial where they basically create a wiki application, a wiki server, right? And I've just taken, so I was going through the tutorial, right? I did the tutorial. Then I saw that, okay, hey, I have this use case. And then I just adapted it a little for my use case. So that's how I went about it.
Nice.
So yeah, so is anyone who's starting Golang, and they just want to get their feet wet, maybe this is a good place for them to get started. I want to highlight that. Cool. Okay. Let's go back to the code. Right. So let's start with the let's start with the main method. Just kill the server for now. Okay. So I have a method called init data, which does some sort of initialization that it is supposed to do. What init data is doing, from what I recall, is before I start serving content, I want to ensure that the server knows what all entries, the comment IDs are present in the different folders. So we have got 3 folders, right? And for each of the folders, they've got multiple files, right? So in the except folder, you've got a few files, and the reject ones, you've got a few files, and the review one, you've got a few files, right? So, and every file has an ID, right? So before I start serving content, I want to create a map that can help me understand that what IDs are present in which folder, right? So that when a request comes, I can basically check where the ID lies, if I'm supposed to take an action, or say if that's an invalid ID, right? So I just want to get a layout of the content, right? Then I'm creating a Go routine called Go routine with the entry method as update, where update is basically supposed to take an action that whenever, say, I move a file from review to accept or reject, right? So I actually end up creating 3 maps, one for review, one for accept, and one for reject. So whenever I move a file from, say, review to accept, I'm going to tell update that, hey, this is the ID of the entry which needs to be removed from review and added to accept, right? Or this is the ID which needs to move from review and to reject. So for that, I created a separate Go routine so that can happen in parallel. So the updation process, right, moving the file from one folder to the other folder, should not block the process of processing the API, right? So the API for say, so let's just actually look at an example, right? So if you just look at this again, right, and say, okay, okay, so say I'm just going to just reject this. I'm not at the content, but I'm just going to blindly reject this, right? So the moment I reject it, it loads up a new entry for me, right? So again, so for me to load up a new entry, I should know what all valid entries are available, right? So for that, I've already created a map when I created this method called init data, right?
Okay.
So when this happened, I created a bunch of entries, right? And say accept. So okay, we hit reject. So when reject was hit, right? So this is, so basically I've registered a function handler here, right? For reject, it's going to go to the reject handler, right? And the reject handler is basically going to pass on the ID to update, and it is going to basically redirect to a new page, right? So if you look at this request here, right? So there is a 302, which is basically a redirection request. So what this basically does is going to redirect. So as you can see, right, on the get URL happened on localhost, right? And what I wanted to do was a redirect. So right, so a redirect happened to a newer entry, right? And for it to find what is a valid new entry, we already have a map of all the entries, right? So all I just need to do is just find a new entry. So right, so when it communicates with the Go routine that I've created here, it will tell that, hey, you know what, remove this entry and basically give me, say, some entry which I can basically show to the to the client, right?
Where is update? Where's the update routine?
Okay, so this is a separate Go routine. We can go over the logic a bit later, right? So this is the logic here, but it's a separate Go routine, so it's running in parallel. Right. So it's basically you've got one thread here, and then you've got the main thread, right? Or as Go likes to call it, Go routines. Right. So the same way it works for accept. And the reason why I've done it this way is moving a file, right, is an IO operation, right? At the end. And an IO operation can take time, and you do not want to block your HTTP request over an IO operation, which can happen in the background, right? So it's as good as, say, if you were, say, using say some other server, right? And so all you're doing is you are basically acknowledging that an action needs to happen, and you are basically saving that action, say, in a queue, and the queue is basically being processed asynchronously, right? So you've got a message queue. So that's the way you may do it if you have if you're following the microservice architecture. So you will have you can have an application server, and then you can have a message queue. And what you're going to do is, say, any action that needs to happen asynchronously, separately from the API call response or the
You put
action
it in
in,
separate subroutine.
right? So you basically create, so you can push it on the message queue, right? And later on, then there can be a separate thread which can keep pulling content from the message queue, right? And do the action necessary, right?
Right.
So we are doing the same update. At least that is what my intention is here.
Right.
Okay, cool. And yeah, so that's what the Go routine here is meant for. And as you can see, and as we have discussed earlier, right? So for the default router that gets created for routing the various APIs that are defined, right? We're just making use of the default mux that handles all this function routing. So we defined a bunch of routing paths and associated handlers with them. So I've got a root handler for the root path, which is nothing but the home. I've got a view path, accept, reject, right, and exit.
Right. So whenever someone opens the browser and visits these paths or endpoints on your server, the corresponding handler function will be called.
Exactly.
Okay.
And then I create a separate Go routine just to initiate the web server, right? Where we call listen and serve on port 8080, right? We're using the default server servmux here, right? And yeah, and so exit is a channel that I've created, right, which is used only for signaling. Okay, so I think we have talked about channels earlier, right? Right. So again, channels is something that is used for sharing data between Go routines, right? Normally, it can also be used for signaling if you are basically sharing very little information, right? So all we basically do here is it's a channel, it's an unbuffered channel, right? So as we had discussed earlier, right? So I can basically give it a size which can tell me the number of entries that it can hold at any given point of time. If that number, which I would assume here is by default 0, that means the moment I write something to it, unless some other Go routine reads from it, right? No more data can be written to it. And if any Go routine tries to write to it, it will be blocked there, right? So the way this works is I have created a channel which basically is used to pass anonymous struct, which basically has no fields. So yeah, so this is basically taking in nothing and is basically being used for signaling, right?
Okay.
Right. So I'm not really passing it any. And if you look at the usage also, I'm not really passing any data. All I'm just creating is a channel. Okay. So coming to the usage, so we have this exit handler here, right? So what are we doing in the exit handler? I'm just giving a response, right? That I'm terminating the server and I'm closing the channel, right? That's all I'm doing. And the only other usage is where I am trying to read from the channel, right? So the only time when I'll be able to come out of, so since nothing is written on the channel, right? And if I try to read from the channel and the channel is unbuffered, right? So the read to the channel will be blocked because there is no content on the channel yet and the channel is not yet closed. So it is expecting that some data can be passed on the channel. So it will block the read here. The moment the channel is closed, right? That means that now there may be some data on the channel, all right? Or just that the channel is closed. So now no more expectation is here. So there's no more reason to block the read, right? So we can just exit. Okay, so we can basically move ahead from the read call here. And once that happens, I can go ahead and basically, print these wonderful statements which say I'm gracefully terminating, but I'm not really taking care of it here, right? So that allows me to close the server. And that is what the exit handler does. It's very simple, right? Let's go to say init data and we'll just then sequentially go over what is happening here, right?
Okay.
So if you go to init data, all it is doing is creating a slice of sync map.
Okay.
Right. So I'll start with this empty slice of sync map. And for all the directories that I have, right, I'm getting a list of files. And for those list of files, I'm creating a map, right? And then for every ID that I get, right, so for the list of files is basically called IDs. And for every ID out of that, I'm marking that as true, right? And I'm appending them, right, to the slice of maps that I've created. And the sync map has an element called ID map, which is what I'm passing here.
Okay.
Right. So let's just go over sync map also once and see why the hell I created it like this. Okay. Okay, so sync map is nothing but just a map, right? And here we are doing something called embedding.
Okay.
Right. So what embedding means is think dot read write mutex, RWMutex, right? Has a bunch of elements in it.
Okay.
Right? Let's just view it. Right. So it has a mutex and it has like semaphores, counter. I think maybe okay, yeah, the number of people waiting to read. So it has all these entries, right, in this structure. I want to add all that I want to add all those structures to this structure that I've created, a sync map, right? So I can either create all these structures and add it here, right? And basically because I have all the just it should have, right? So if you look at it, right, so RWMutex has some associated functionality with it, right? Basically it allows me to perform read locks and write locks. So it basically implements the reader writer interface, right, where I can access content with blocking. So if I'm basically reading some content, I can add a read lock on it so that if someone is going to write, they will know that yeah, there are people reading, so they'll basically block their write till say all the reads are done, and then they'll go modify a write. And when say a write is being done, then all the reads will be put on hold. Right? Right? As you can see, it's a reader writer mutual exclusion lock. Right? Arbitrary number of readers or a single writer. So I want this functionality because the way I think about it is that I can have say 2 separate tabs here, right? I mean, this is probably not what I'm going to do, but if you think about it, it can be the case that maybe say, hey, I open 2 separate tabs, I was performing actions, and say the same entry that I have opened in one tab comes up here, right? And if I try to do an action, again, the risk case is not going to happen, but if you think about it, or I was just maybe over engineering, is I wanted to handle the case if say a request comes on, basically performing an action on the same entry, right? So that is going to cause an issue. Say on one entry I say accept and on the other I say reject, right? How is that going to be handled? Right. So I just wanted to add a lock for the heck of it, right? So what embedding does is it allows me to add the structure here, right? All the elements present in the structure will now be part of this bigger structure called sync map, and all the methods which are associated with the structure, right, are now also accessible because all a method looks for is whether it has all these functionality, it has all these elements available, right? And the one that I created has all those elements available. So yeah, it will allow me to use that functionality.
Okay.
Right. So because at the end of the day, this is, if I understand it correctly, this is duck typing. So all you're just checking is, hey, is the structure that I've been given has all these elements? Yeah, it seems to have all these elements. So of course, I have all the required entries that I need to, execute this function. So yeah, I will allow this functionality to be executed on the given structure. Right? That's my understanding of it. Okay, so that's why we had a sync map, because I wanted to add a map with a read write lock functionality available on top of it. And sure, layout is nothing but a slice of such sync maps. Okay, cool. So for every directory, we create a map and we create a sync map structure, add the map to it, right? So the map is encapsulated by this structure, and sure, I just append it to this list that I created at the start, and I'm returning this list. So when I get layout, right, what happens is for all entries in all the given folders, right, I already have a map of which ID is present in which folder. Right. Or let me put it another way. That's not probably the right way of saying it. For every folder, I know what I know all the IDs present in it.
Yes.
Right?
Yes.
With the use of the map. Right. And that's what I can query. Okay. So let's go to update. Right. Okay. So I have created something called an update chan. Where is it? Yeah. So I've created again a channel, right? And this time it's a channel of messages. As you can see, a message has 2 entries. One is the ID, which is going to be your file ID, right? Which is again the same as the comment ID. And the other is going to be your destination folder, which I've described here as which the data type here is a string. So, so what I'm going to do is for every entry that needs to be moved to say a destination folder, I'm going to create the structure which is going to say, hey, for ID X, you need to move it to say folder accept. That is going to be my message. I'm going to send this message over this channel, right? So whichever go routine is reading from that channel can take the required action in response to this message. That's all the channel is there for, just passing this information. Right? And this is this is a buffered channel, right? So it can buffer up to 100 such messages. So now you would want to think, why is this a buffered channel, right? It's a buffered channel because, say, if I add a message on the channel, right? If it was an unbuffered channel, no new entries can be written to the channel till the entry that was written earlier has been consumed, right? So at any time the channel can hold at max one message, right? And say if the IO activity is taking some time, a new message cannot be added. That means the API response cannot be sent for, say, any API action that has been requested, right?
Right.
So that becomes a choke point, right? Because I can have only one message on the channel, right? So you want to add a buffer, which allows you to buffer up all those actions, right? So that is why we have added a buffer of 100. Not really going to hit that in our case at any day, but sure, why not create it yourself, right? So got this update chan, right? So what it does is just got a big for loop, right? So the expectation here is okay. So one of the things that probably I should have added here is added some sort of an exit condition. So that's not there because this is somewhat half-baked code. So right now it's just an infinite loop where I'm just going to execute some functionality. But if this was implemented properly, I would have, say, some sort of an exit condition, which would probably be that I am done with all the entries, right? So there is no further action that can be requested by the user. Or say, as I was talking about earlier, right? Say I get a API request from a client asking me to shut down the server. So you would want to probably add some sort of exit criteria here to handle that scenario, which I'm not doing right now. Okay, so that will be some form of graceful exit handling that I can add here.
Okay.
Right. So, okay, so what is the core logic implemented in this infinite loop? So I'm getting a message from the channel, right? And what I'm doing is getting the index from mdest. Okay, so what that basically means is I have this list of maps, right, that I had created earlier, right, and I had assigned it to layout, right? So I need to figure out which is the entry that I need to update, right? So there are 3 folders: review, accept, and reject. So for accept or reject, I need to figure out what is the index. So that is what get index does. That's all it's doing. And I've already created like does, right? We're just going to figure out what is the entry. Whoops. That is what get index will do. So get index. So you get the sync map from that. And what you do is you perform a lock on it. So you lock the map and you just check if that entry is present in the map or not. And if the entry is not present, then you mark that the entry is present in the map. You mark it as true. And why is this working? Because the default value provided by the map will be false if the entry is not present, right? So if an entry is not present in the map is going to provide you the default value of the return type. So in this case, the return type is a bool because we've created a map of int to bool. So the default return type for bool will be false, right? So if that entry is not present, I'll be getting false, right? So that is why I'm going to go ahead, and then if the entry is not present in the required folder, then I will basically go ahead and mark it as true, right? And perform an unlock. Sure. So I should make a comment, handle the other condition. So I'm not doing that here right now. So that is something that I should be doing. Right. And so that's one more thing that I should be doing. So that is that. And then I've just hard coded this. It should be not hard coding, but yeah, I know that the review folder has index 0. So I've just been lazy here. So I just hard coded to 0. Whereas what I should be doing is, I mean, at some level or the other, I'm just going to hard code something or the other. Why is this up? Right. Yeah, this is how it should be. Right. And then, yeah. And if that entry is present, then yeah, I'm going to mark it as false. Right. So that is what is going to happen. This is where I'm just converting the ID to a string, just creating the old path and the new path, right? And then I'm just asking to update the file path, right? So just going to rename the file. Just going to move it from one location to the other. It's basically your move utility, right? That's all the functionalities that is being provided by the source.rename, giving it an old path and a new path, right?
Yep.
And if then there is any error, I'm just going to log that error. Okay, something went wrong.
Nice.
Right? And just move ahead.
Right.
Right. So this is all the update Go routine does. It's just going to keep updating the indexes, right? Sorry, keep updating the maps for all the folders, and it's just going to make the relevant movement as required. Okay, so one of the scenarios that I've not handled here is, say, if again, if there are, say, two separate tabs, and say one of them clicks on accept and one of them clicks on reject, right? I am serializing.
Probably fail, right?
Yeah. So say so this channel will like at least serialize those requests, right? So say accept comes first, so the accept path works fine. But say if I go on reject, right? So that is, say, in this current code, reject is also going to work, right? So it's going to, right? So it's going to search for the reject map. It's going to check, hey, is that entry there? No, let's add that entry there, right? And yeah, I'm not doing any error handling here. Sorry, I'm not doing any handling for the other condition here, right? In the else case, right? So that's why it's just going to silently ignore that, and it's just going to try to move the file, right, from review to, say, reject, even after I've moved it from, say, review to accept. So yeah, that's one of the error cases that I've not handled here.
Okay, let's fix that. So how would we go about fixing this?
If you want to go about fixing it, what you want to do is basically, first of all, move this here. What you want to do is, say, move it here, because you want to check here if, so you go to the review folder, right? So you go to the map of the review folder, and if you want to check that entry is there, right? So if the entry is there, then you want to set it as false. But if the entry is not there, I just want to continue. Why? Because there's nothing for me to do, right? So if the map did not have that ID, that means the review folder no longer has that file, right? Correct. So there's nothing else to do.
But then should it redirect to another?
Yes, it should redirect to another one, and let's see how that is done. Unfortunately, I have not implemented that method here because there is no way of communicating. I've just set up a one-way channel from, say, the main routine to, say, this core routine. I've not implemented another channel for me to, say, share the new IDs from this core routine, say, to the next one, to, say, the main one. Right. So that's not there. So for now, let's just keep it at continue, right?
Okay.
Right. So sure. So if it is not there, right? And I don't think then we need to handle this condition, right? So because if the entry is there in this directory, right? Then if the entry is there in this directory, then sure, when I come here, I'm okay with doing this operation, right? Because the moment, so the benefit of applying locks here is that, say, at any point of time, only
one go routine
should be able to go ahead and modify this, right?
Correct.
Well, technically, this is the only go routine which is modifying it, but since this is the global structure, sorry, the entities can be accepted globally, right? So let's not assume that it is okay to perform these operations without locks.
Right.
So since I've locked them here, right? So at one point of time, say, only one entity can go ahead and modify, say, one go routine can go ahead and modify this, right? And once this modification is done, right? So the next entry is going to, when it does this check for the ID, same ID, it is not going to find it. So it will be a false condition, right? In which case we are doing nothing, right?
Yes.
So the only scenario that we have to think after this line number 191 is that, okay, I have marked the entry as removed from review, right? All I now need to go ahead and do is, say, just update the relevant, say, accept or reject map to contain that ID, right? And that's all we are going to do here, right? So I don't need to handle the other case here.
Sure.
Because if it is not present, then I want to update it. If it is present, then I'm cool with it, though I should not encounter the situation where is already present, because if it is already present, then this should have failed. So that should so that way we are covered in that sense. Do you get it?
I'm still trying to wrap my head around the second case.
Right. So think about this. So either you have the entry in the map or not, right? So if you have the entry in the map, right, which is the other case, which will be the else condition, that means that someone has already added that entry, right? So if the entry is already there, we are okay with it, right? Because that is what we are trying to do at the end, right?
Right.
So it's anyway accomplishing the action that we are trying to perform here,
No,
and we're
there's
okay
no
with that.
point trying to set something to true if it's already true.
If it's already set to true, right?
Yep.
So that's the logic. So yeah, so that's that, and yeah, this is where you're applying it. So I think yeah, that should fix it. And yeah, graceful handling, yeah, I think I'll have to tackle it a bit later, because that's not going to be that straightforward. Okay, so that is update, right?
Yep.
Now let's just go to say view handler, right? So view handler does a very simple thing. It goes to get job ID, okay, right? And what am I doing there? For the given URL path, I'm going to find the entry. That is the ID. So what does find string submatch do? Oh, so yeah, so it is going to.
So this seems to be part of the regular expressions.
Right. Okay. For a
module.
given regular sub expression. Okay. Okay. So yeah, I think I remember now what it does.
Mhm.
So I have created a regular expression here,
Mhm.
right?
Mhm.
And again, inspired from the wiki tutorial on the Golang page. So what we do is we basically create a regular expression which specify what are the valid endpoints. So say I create this as ABC, right? And it's going to give me a 404,
Mhm.
right? And the reason it's going to give me a 404 and the root handler is not going to handle that case is because I have created this condition.
Okay.
Right? Where for every handler, I am checking if this is a valid, if the URL that has been requested by the client, right, matches the regular expression that I have. If it does not, right, I am just going to crib about it.
Okay.
Right?
Essentially, what that regular expression says is it has to start with the root path.
Right. So it has to start with the root path, and it should be either accept, reject, or view, right? And then it should have like an
alphanumeric.
Right. Well, in our current case, technically we don't even need alphanumeric. This is what it should be.
Yes.
Right? Because
any number of numbers, any number of digits.
Yes, that is what we are supporting, right? And if the given entry supports if it matches the given, okay, so if the URL path satisfy the regular expression that we have, then I think the find string submatch should split the URL path into a string slice.
Okay.
That is, I think, what it does, because what I'm actually passing back is the second entry in the string slice. Right? That's all I'm doing. Because what is going to be the second entry? So this is going to be a first entry, and this is going to be the ID is going to be my second entry. So I think this is going to be entry number 1. I mean, coming from index 0, 1, 2. So I think this will be 1 and this will be 2. That is why we are going for M2 here on line number 90, right? And if I think the regular expression, if the given URL does not match the past regular expression, then yeah, I think the response that we're going to get is going to be a nil, in which case I give it a 404, right? So I create a message and I'm also going to return, say, an error, which if I want to log it somewhere, I can log.
Okay.
Oh, okay. I think I now know maybe where I screwed things up a little. What if I did this? Okay, I think I seem to have fixed the problem. So I just realized what I was doing.
Okay.
I was calling HTTP not found twice, basically. Calling it here once in get job ID, and then calling it once in this function handler that I pass in the
which is why
router.
we used to get 2 404s.
Yes, which is why you had 2 lines, right? Giving you this message 404 page not found. So awesome. I at least figured out what was the issue there. And I'm just creating a new error here. But I am not really using, okay, I'm just using the error here for logging purpose, right?
Okay.
That's all I'm doing with the error.
Right.
Okay. Right. And yeah, if I'm getting, if I actually end up getting the intended ID, right? So I'll get it here. So I'll not get an error if I get the intended ID. So if I get an error, right, I am just going to log the error and just return a 404. I'm just going to return from the method. If not, I get the ID. Yes. So this title is a remnant of old code that I had adopted. Right. So yeah, that's why it's called title here, and then I've got an ID here. That's why it's just named weirdly. Right. So yeah. So the ID that I get here, I convert it to a string. Just try to ensure that there is no issue in string conversion. Once that works, right?
Okay.
That is when I am going to load the content of the file to an HTML page, right? So I'll do that, and I'll just come to load page in a minute. And if that fails, then I'm going to, again handle the error condition. Otherwise, I'm just going to render the template. Okay. So what does load page give me? Okay, it gives me a page pointer. Okay, let's see what it does. So what does load page do? Okay, so load page goes makes a read log on the index. Okay, so index is 0. I could have done this, right? It performs a read log, and yeah. And okay, so it will try to search if the ID exists in the review folder, right, in the map. And if it doesn't, it is going to give an error, right? Entry is not present. Right, that's all it's going to do. And if it is there, then it's just going to read the content. So yeah, it's just going to create the file name, just going to read the file content, right? Add it in the body, and then yeah, that's what it's going to create. Got a page title called job. That's where the content of the comment is going to go, and ID is just a name. Yeah, but poor naming convention here, but yeah, that's it.
So I remember you showing me that the HTML contained 2 divs.
Yeah. So this is we are just coming to that, right? So right now I've just read the content of the comment into and we have passed it in this structure, right?
Something called page. Okay.
Right, something called page, where the content is basically the body. Yeah, right. Say once we have that, view handler, right? So once you've got load page, right, we go to render template. So this is what we're going to do here. So okay, this is an optimization, but okay. So what it is going to do is it's going to make use of this variables, this list of templates, and from the list of templates, I'm going to tell it, hey, this is the content, this is the template name, right? And this is the response writer, which is the buffer on which you need to basically write the outgoing content, right? So the HTML content is going to be written to the response writer, right? And what it is going to basically do is execute template will take the content in the page structure and apply it to the template name. So using the template name
again here.
I'm just coming to that. So the template is an HTML template, right? However, the template name here is basically just a key to find the relevant template content, right? And using the template content and the body that we have from this page here, we will create HTML content, which will write to the response writer. So let's just go to templates once. Right. So what is template showing here? So we've got the template package, right? Text/template, which you had queries about earlier in our discussion, right?
Yep.
So what it does is I'm giving it a list of files, which it is going to parse, and all these files are going to be our template. So let's just look at this. So this is the view.html template. Got a template folder. Let's go to view.html. So what does view.html have? So it has an HTML template, right? Where I've basically created all those 3 buttons, right? Every button had an action, right? So I had the accept, and this is the ID value, right? That we had generated dynamically, right? So this is the template, and we get the associated structure with it. And from the structure, we're going to extract values, and we're going to feed them here.
Okay.
So the structure had an ID field, it had a title field, and it had a body field, right? So we're going to extract those elements from the structure, and we are just going to paste them here. That's how you can just think of how the template is being used, right?
Hmm.
So you are just going to add the entire content of the body here. You're just going to add the title here. That's why it just says job, because the title is hard-coded as job,
Yes.
right? Okay, so that's all it does.
Nice.
What this does is basically this template.mask. What it does is you give it a list of files, and it creates so it loads the template only once, and it stores them in memory, so that you're not loading the template from the disk every time that you are trying to make use of the template. So you just load them once and you just store them in a variable, right? So your template.mask is basically providing you that functionality. You just give it a list of template files, it will load all of them and just keep them in memory, right? You can access them using this variable. So you just give it where to write the final output, give it the name of the template that you want to use, and give it the content and give it the structure from using which the template will be filled, right? And that's it. It will create the HTML content for us, right? And if there's any error, right, then we are just going to say 500.
Okay.
Just give a 500 response, right? Something went wrong on the server, right? So that's all I'm going to do. So that is what happens in my view part, right? Very simple. From the URL, I just extract what is the ID. From the ID, then I just load the content from the disk, right? And once I have it, then I just tell it, hey, take the view template. Here is the content to be added to the template, right? And just write it to the response writer, and I'm done with it, right? So that's what happens in the view handler. Let's just go to the accept handler. The accept handler basically does similar work, right? So if you look at it, right, so to look at what happens in the accept handler, it makes one call, so basically the accept handler, right, you perform a get call, and we are basically giving it a 302. So we are redirecting it, right? So what you want to do in the accept handler is you want to take a note of the file which needs to be moved from review to accept, right? And you also want to basically redirect the client to a new ID field, to a new comment which should be rendered by the server, right? So instead of adding all the logic here, what we do is we just redirect them to the URL where we just find a valid ID, right? Which can be viewed, and we just create a view URL, and we just tell them, hey, you know what? Just go to this URL, and yeah, you'll get something to view, right? That's all we are doing.
Right.
So if you look at it again, we're getting the ID, right?
Right.
And yeah, if you get right, so we're getting okay, my bad. Right, so we're just getting the ID from the URL, and okay, whoops. So line 133, we're getting the ID that needs to be acted upon, right? Performing the basic sanity checks, right? And what we are doing at line 146 is, hey, this ID needs to be moved to the accept folder, and this is the message that I'm passing on the update channel, right? That is all I've done. Once this is done, I go to get random ID.
Okay.
So what get random ID will do for me is it will fetch a random ID which is available in the review folder, right? And using that, I'm going to generate a URL path, right? I'm just going to generate a view path for it, and then I'm just going to redirect it to this path.
Okay.
Right. That's all I'm doing. Fairly simple, right? And let's just go to get random ID, right? So get random ID does not do a lot of things. All it does is has a default ID value of -1, right? Right. So that was what it should do. Should maybe even hard code this. Okay. Because I've repeated this line of code at least at 3 or 4 places. I think I should just hard code it at one place. Okay. So yeah, so you get this entry, right? So you get the relevant map, then we perform a lock on it, and what are we going to do? I just pick the very first. So I am just iterating through the map, right? And I just pick the very first entry that I get from the map, right? And I return it.
Okay. So
that's all I'm doing.
It's not that random.
It's not that random, but what actually happens is that the iteration over a map is not deterministic.
Oh, I see.
Right. So by default, the iteration over a map, if you do it twice, both the times you can get different results.
Oh, okay.
Right. Even if the map is not modified. Because map is, if you think about it, it's an unordered collection, right? So since there is no order, so the iterator cannot guarantee you that you're going to get the same result every time. you iterate over the map.
Hmm.
Right. So if it was an ordered collection, then yeah, it should give you the same result over multiple iterations. But since that's not the case, right? So in that sense, it's somewhat random.
Hmm.
Right. Now that I think about it, I think we can live with a read lock only. We don't really need to lock, since all we are doing is just reading from it. We don't need a write lock. That is one thing that we can probably do here.
Okay.
Okay. Yeah. So yep. So that is what it does. So it should basically pick a random ID, and yeah, it should allow me to proceed ahead.
Okay. So we are relying on the inherent non-deterministic behavior of iterating over a map to select a random item from the map. Cool.
Cool. So as I was saying, right? So accept handler and reject handler have the same functionality, except for the fact that yeah, in reject handler, all we're just doing different is basically when we're creating the message, we're just mentioning that yeah, I want to send it to the reject folder. That's
Right.
it.
Right.
Right. And I think I've already gone over the exit handler, right? Where all we're just doing is yeah, terminating the server, and yeah, I've gone over the view handler. Let's just go once over the root handler also. So, and the root handler is not doing anything major. All it is just doing is just yes. So if you are redirected to the root handler, right, it's just going to check, is it the root path, right? If it is not the root path, it's just going to send you a 404, right, not found. And if it is the root path, then it tries to forward you to this view front page.
Right now it's not implemented, right?
It's not implemented because, as I said, right, I had based it out of the wiki tutorial that was there. So they had this concept where you could just where the root path on your server could redirect you to like a default page, right? That was the front page. So yeah, in the sense, if I am going to create a front page here, right? So what that will be, it will basically be a page where I list out all the valid IDs so that the user can click any one of the IDs and then go to that page, right?
Yeah, right.
But yeah, unfortunately, I have not implemented that logic yet.
Sure. Okay.
Right. So it does not even need to be say /view root page. I can just whenever you're accessing the root folder, I'll just give you a bunch of entries that can be viewed. Right. So that's one to do. Let me just add it here. Right. That's it.
Super.